miles an hour heading north.
Or given the fact that I said up was positive 20 miles per hour. Average velocity only cares about where are you relative to where you started, how much time did it take. So if I die in the bed where I was born, my average velocity for my lifetime, 0. So now let's get into, make it a little bit more competitive here. I'm in a race with Usain Bolt. Running around a track, 400 meters. We take off. We run around the track. This is our starting point. This is the end point. Usain Bolt does it in, we'll just say 20 seconds. That's Usain Bolt. And I do it in 120 seconds. Let's make the math easier. We'll just say 200 seconds. Which of us has a higher magnitude of average velocity?
Usain Bolt.
How did you get that?
Because it's divided by a smaller yeah, it's divided by a smaller number.
What's divided by a smaller number?
The distance traveled.
But I asked for magnitude of velocity, average velocity.
Oh.
What is, when he gets to the end of the race, what is his displacement?
0.
What is his average velocity?
0.
When I get there, what is my average velocity?
0.
I'm as fast as Usain Bolt. Matter of fact, I can faster than Usain Bolt because when he finishes, I am not there yet. I am here, and he's here. His average velocity is 0. Mine isn't. Magnitude of my average velocity is not 0 because I have gone somewhere. In 20 seconds, he's gone nowhere. In 20 seconds, I have gone somewhere. I'm faster than Usain Bolt. Now, if you wanted to, you could look at speed instead of velocity. What would be Usain Bolt's average speed for the race?
20 meters a second.
Did you say 40?
20. I said 20.
20, okay, yeah, 20 meters a second, and mine,
2.
and that probably is, let's do the whole thing.
2 meters per second.
Yeah. And that probably is the right relative difference. Now I can do more than 2 meters per second is a slow walk. My class is okay. It works. All right, so velocity versus speed. So when dealing with a plus minus negative, since default is instantaneous, what I care about is the direction that I am moving in. So right now, am I moving in the positive or negative direction? Going back to, that's the origin, that's my starting point, positive is that way. Let's change the problem. What's the direction of traveling in?
Negative.
So what my velocity is?
Negative.
My velocity now?
Positive.
All right, let's see if we can get everyone to say it in unison. This will be awesome. We're gonna bring tears to my eyes, potentially internally. My velocity?
Positive.
Position?
Negative.
Negative.
Displacement?
Positive. Negative.
Negative. My starting point's over there. Yeah, we're not worried about, this is still the starting point throughout the entire problem. Position?
Positive.
Displacement?
Negative.
Velocity?
Positive.
Velocity?
Negative.
Position?
Positive.
Positive.
Displacement?
Negative.
All right. Questions up to there? Or is it about to make it more difficult? Next level. If I'm dealing with how velocity changes, that is called acceleration. Symbol, A with a vector symbol. It's supposed to be an arrow. And it is the rate of change of velocity with respect to time. Or mathematically, acceleration is dv dt. Or second derivative of position with respect to time. This would be instantaneous. And then average change in velocity over change in time. Since acceleration is based upon how velocity changes, if you're driving a car, what are the 3 accelerators that you have access to? Assume automatic transmission for the sake of this.
Gas pedal.
Here's 1,
Brake pedal, maybe.
2,
Emergency brake?
going along with the brake. That's braking.
Colliding with something?
Pardon?
Crashing into something?
It's slowing down. Yes, you do have access to crash into something. Let's assume just normal standard. You got brake pedal, you got the gas pedal. One speeds you up, one slows you down. What's the other way that you can accelerate?
Gravity.
In neutral.
As in you go off a cliff?
Well, you go down a hill.
Oh. That's more of a function of the road itself as opposed to something that you are controlling.
Could you push it in neutral?
That's still going to speed up or slow down. You're missing the other. Remember, we're dealing with a change in velocity. What's velocity?
You can reverse. Turning.
Turning. If you change directions, you are accelerating. So your steering wheel is an accelerator from a physics point of view. Brake pedal, gas pedal, steering wheel are all accelerators. Now, why does this matter? Because it turns out, jumping ahead just a couple chapters here, is that there's a relationship between forces and acceleration. For those who haven't had physics, I consider this to be the most important equation in all of physics. The fact that the total force is equal to the mass of an object times its acceleration. So if I'm accelerating, there has to be some net force acting on me. If I'm not accelerating, then the net force on me is 0. So if acceleration is 0, and that's a 0 vector, just because officially if I have a vector on the left-hand side, I have to have a vector on the right-hand side. If acceleration is 0, then my velocity is 0. Change in velocity is 0, and the total force is 0. If any one of these is true, the other two are automatically true. If any one of these is true, and all of them are, therefore all of them are true, this is known as equilibrium. Now, so for chapter 2 and 3, we'll be concentrating on these two. For chapters 4, 5, and 6, this is the issue. Actually, 4 and 5, 6 is definitely not equilibrium. There was a test question last spring of which of the, I set the situation, I said it was an equilibrium, therefore what must be true for the following. And I had acceleration, change in velocity, velocity, total force, and various other things. And I'm not, this is no comment on whether the velocity is 0 or not. That is beside the point. What we're commenting on here is whether the velocity changes or not. Now, I was not consulted on the next bit. It is just a reality that you have to deal with. The scalar analog of the acceleration is acceleration. The symbol being just the letter A. So if you're given a quiz or a test or a homework problem and it asks, what is the acceleration? Which one are you answering? On a test or quiz, if I've gotten better about this, about after I ask, if I'm asking for acceleration, I'll put a comma and then I'll put either A with a vector symbol or A without, just so you know which one I'm talking about. Textbooks, typically, the acceleration they're talking about is the vector one. All right, so now, back to plus minus zero. Oh, questions before we do plus minus zero with acceleration. All right, so let me start here. My position,
Positive.
displacement,
Zero.
velocity,
Zero.
acceleration.
Zero.
I start to move. What was my acceleration when I started to move? Just then.
Positive.
Zero.
All right, we've got all three answers out now. It's one of those three. What's the argument for zero?
You want to know speed?
So since acceleration deals with change in velocity, if I'm starting out with the velocity of zero and it doesn't change, how can I move?
You don't.
I think let's just accept for right now that I did move from that spot over there. So it's not zero. That's a common mistake. All right, so argument for positive.
You're going faster than you were when you started.
All right, so I was asking about this. This is the acceleration I cared about. Still stick with the same argument?
No. You're moving away from the starting point.
Not the bigger issue.
Your velocity went from 0 to negative.
That's the reason. That's why my acceleration was negative. So my acceleration was negative because I started at 0 and I go to negative. Now I'm cruising along at a negative velocity and I stop. What is my acceleration as I'm stopping?
Positive.
Why?
This is going back to the 0 direction.
Okay,
Velocity is being less negative, becoming less negative.
it goes from negative to 0, so therefore that's a positive change. All right, we're gonna be quick on the responses here, so because I'm gonna run out of room. Velocity,
Negative.
displacement,
Negative.
Negative.
position.
Negative.
I turned around. What was my acceleration when I turned around?
Positive.
What's my acceleration when I turn around?
Negative.
If someone said they had negative acceleration, what would that mean?
They were accelerating in the negative direction towards a larger negative velocity.
Not necessarily. All right, my velocity, I have a velocity here that's positive, and I come to a stop. What was my acceleration?
Negative.
So I'm not going to a greater negative value.
They changed direction.
In that case right there, I didn't change direction.
It's moving closer to 0.
Not necessarily. Because when that example back here, when I was started at 0 and it became negative velocity.
Slowing down.
Pardon?
Slow it down.
Not necessarily. That's the most common misconception. There are a couple variations of that here, but if you can break yourself of thinking negative acceleration means slowing down, life becomes so much simpler for you and for me when I'm grading. Correct answers are easy to grade. Just keep that in mind.
So how would you define?
Negative acceleration?
Yes.
There's two ways. One, you are going to a numerically smaller velocity. So if your velocity is positive, you're slowing down. If your velocity is negative, you're speeding up in the negative direction. The other way, and I don't want to use the marker on the board here, is that acceleration and force are the only two vectors in this equation here. This is known as Newton's second law, by the way. So acceleration and the net force are in the same direction. There are only vectors involved. So if my acceleration is negative, that means the net force is negative. If acceleration is positive, the net force is positive. There are times in which that's the easiest way to look at it, and times in which it is the change in velocity, looking at it with your speeding up, slowing down. We can also look at it as in, if I'm going in the positive direction and I get pushed in the positive direction. So my force is in the positive direction. What's going to happen to the acceleration? What will the acceleration be?
Positive.
Am I going to speed up or slow down?
Speed
Okay, I think that was
Speed.
not just an okay, but a thumbs up. Speeding up. If I'm going in the negative direction and I get pushed in the negative direction, what am I going to do?
Speed up.
Is my acceleration positive or negative there?
up. Negative.
So if acceleration and velocity have the same sign, if same sign, I'm going to speed up. So I can look at a problem also from the point of view, am I speeding up or slowing down? And that will give me a hint as to the same sign if it's speeding up, they're opposite signs if I'm slowing down. So if acceleration and velocity, opposite signs, then slowing down. You know, at some point you need to get used to, my NG often gets blurred into something looking like that. I throw a ball into the air. Well, let's just actually run through that problem. Questions up to here before I erase? All right. Now, on the first test, there's going to be the last problem on the first test will be a problem more complicated than what I'm about to do. If you look at some of the older tests, it was like this, but I've gotten more and more complicated as I've gone. Ground. And I'm going to make this is position is 0. In essence, that's my origin. It's going to be a one-dimensional problem. We'll make it up positive. I have a ball being thrown into the air. It's going to go up and then come down. So I'm going to label point A is the time at which ball leaves hand. B is the time at which ball is at peak. C, the time at which ball is at same location as at time A, but going down. And D, time just before ball touches ground. All right. So if I had to label the times as the location of this ball, it's that at time A, it is here, at time B, it's here, at time C, it's here, and at time D, it's there. So what we're gonna do is try to identify plus minus 0 for the 5 basic vector functions here. Position, displacement, velocity, acceleration. Set up the grid. All right, so let's start out with the simple ones. Oftentimes it's easiest to first identify the 0 spots and then go from there. So at what time is the position 0?
Do you mean in terms of the origin or in terms of the, what's it called?
Starting point?
Yes.
Position is origin.
Okay, so,
Think post office, P-O, P position, O origin. Or Ocean Pacific if you'd rather.
would it be D or A?
Where's the origin?
A?
I defined it on there.
Oh. So it's a D. D?
It is not D. Why is it not D?
The time just before it touches the ground.
Yeah. The ball actually never touches the ground in this particular problem. So this is at no time, and we can, stunning visual effects. When is it? Negative?
Never.
Not applicable. And so it's positive the entire time. So from time A to time D inclusive, that's why I'm doing the square brackets. That's when it's positive. It's positive the entire time. I know, not particularly exciting, but don't worry, the test problem will be exciting. So displacement, where's the displacement equal to 0? At what times are the displacement equal to 0?
A and C.
Yep.